Okay, so now we're going to talk about very straightforward force diagrams that you should already know how to do, but in case you have forgotten because it's the end of the year, this is a good review. We're going to talk about most of the spots on the roller coaster, what I expect an average person in physics, everybody, to be able to come up with. At the beginning of the roller coaster, it's either on a slope, straight up and down, or actually you're dropping it in the air. There's somewhat different force diagrams for each of these three. We're going to do all of them. Yours will be one of them. For every single force diagram, there's the weight of the marble. The weight of the marble always goes straight down. You can call it the force of gravity and say it's on the marble from the earth. And it's equal to the mass times the acceleration due to gravity. I've been using 10 for my acceleration due to gravity. So if I have 0.005 times 10, I'm going to get a weight of 0.05 newtons. So that gives me a number on this weight. And if the marble is just being dropped, that's it. There's only the force of gravity on the marble. Every single force diagram that you have should have the force of gravity on the marble because the earth doesn't go away and it's always pulling on the marble. I'm not always going to write out these things, the thing the force is on and the object is also interacting with the object, the two objects interacting for the force. You can do that. I think you'll know what they are. I'm just going to start abbreviating some things. So here I've also got the force of gravity of 0.05 newtons, and here I've also got the force of gravity of 0.05 newtons. Notice I had the force of gravity go straight down there. It doesn't go down the ramp, it goes literally straight down towards the center of the earth. Every single marble should have the force of gravity on it. If it's touching the ramp, it should also have the normal force. So the normal force is perpendicular, I wanted that to be red, perpendicular to the ramp. So normal is on the marble from the ramp or the track or whatever you want to call it. And here I haven't calculated out what that normal force is. I haven't figured out a way to get that number yet. And there's also a little friction parallel to the ramp. So normal force is always normal, which means perpendicular, and friction is always parallel. You can put a tiny little drag force on it too. I'd rather you didn't, but you can. I won't take off points for it. That's from the air that the thing is going through. We're hoping the drag is very, very small. We know friction exists because otherwise our marble would be so fast at the end, and it clearly loses energy. That's why it can't get up the loops that you think it should get up. If you're really straight down, there isn't any normal force. The normal force would go out, but the marble isn't actually going in that direction. So this is kind of just falling. It might be falling and rubbing up against it, so it might have a little force of friction. It might even have a little normal force, but I would only do a normal force if you have any angle here at all. I wouldn't do a normal force if it's really straight down. This is basically what you would expect for either a ramp or a straight down or just in the air. If you're in the air in the middle of a jump, like you went off a projectile, like my 0.7 here, where it's like in the air, then still the only force that's on it is the force of gravity. I don't want you to do a drag. I guess if you did a drag, it would be opposite to the direction of motion. But that's basically what's going on for those. The last point that I have is completely flat, 0.9. If something is completely flat, then again, like always, we're going to have the force of gravity, and we know what it is. It's 0.05 newtons, and we're going to have the normal force and the frictional force. Because it's not going up and down, we know that these two forces are the same, so that allows us to figure out what the force of friction really is, what the normal force really is. It's got to be equal to the weight, and that's 0.05 newtons. We've already figured out what to do if the object is on a ramp of known angle. Like let's say this is a 30-degree angle, and here's my marble. This is kind of like 0.6, only I reversed it. I'm going to have weight, the force of gravity of 0.05 newtons, and I'm going to have normal force, And I actually can figure out what the normal force is. You know how to do that because instead of looking at horizontal and vertical, we're going to look at down the ramp and into the ramp. So we're going to take the force of gravity and we're going to break it into components. These two components, the one into the ramp and the one down the ramp. If this is 30 degrees, this is 60 degrees. If this is 60 degrees, this is also 30 degrees. I'm going to blow up this triangle. It has a hypotenuse of 0.05 newtons. It has a 30-degree angle at the top, and it has two sides. This side is the adjacent, so it's going to be the hypotenuse times the cosine of the angle. And this side is the opposite, so it's going to be the hypotenuse times the sine of the angle. Those I would do on my calculator. 0.05 times the sine of 30 is 0.025 newtons. And the cosine of 30 times 0.05 is 0.043 newtons. So now I know that this little part here is 0.043 newtons, and the downhill part is 0.025 newtons. Because it's not moving into or out of the hill, I know that the normal force is the same as that into the hill component of gravity. So if that component of gravity is 0.043 newtons, this component of gravity is also 0.043 newtons. And I've got a number for my normal force, which gives me points. I've also decided that there's a force of friction on this thing, and a long time ago I decided that the force of friction was 0.005 newtons, so I'm going to keep that decision going. My force of friction is 0.005, and the downhill part is 0.025. So if I want, I can find the net force downhill by doing the downhill force of 0.025, that's that piece of gravity, and subtracting the frictional force. So 0.025 newtons minus 0.005 newtons gives me a net force of 0.02 newtons. Net force equals mass times acceleration. So now I can find my downhill acceleration, which also gives me some points, because I know how to do that. So 0.02 newtons divided by 0.005 newtons tells me that my marble is accelerating with an acceleration of 4 meters per second squared. So all of this physics is physics you should know how to do. It will be on your final exam. It's not too hard. This one was a little tricksy because we had to break up the weight vector into components and do a little net force math. All the other stuff here was basic, easy forces.